Hey, all my JavaScript friends, this is the Virtuoid, aka Mike Smith, and today we're taking a look at the test for the game object for our Davenport game. If you like this video, please click on the like button below, subscribe to this channel, or leave a comment. I'd love to hear from you. Okay, so this is the final class we'll be developing before we actually develop the browser version of the game. And this is the game class. What does it control? Well, it controls the game. Basically, it allows us to start the game, initialize the game, which will allow us to deal out the cards, set up the number of players, all that kind of fun stuff, and actually start and run the game. So what I'm going to do here inside my classes, I'm going to first of all create a game directory. And I'm going to create a game class. And we'll just do it export default, if I can spell, class game. And that's all we're going to do with this particular part here. So in the integration section, we're going to create a new directory, call that game. And let's go ahead and just do the constructor. And then what we'll do is we will take a look at what I think is going to be needed within the constructor. So let me throw some code over here. Okay, it's not really code, it's just comments. And so basically, this is kind of how I envision the object or the game object to work. It's going to take two arguments, an ID and a players, which is the array of players. This is the player that we've created in earlier videos, and a UUID array, ID if we don't specify an ID. So here's the process that's going to happen is that basically a game is created, which is what the constructor is for. A new deck is initialized and a player's dealt a starting hand. That's going to be inside of an initialize routine. Then rounds are going to be played until there's a winner and the game is over. And that's it. There is nothing else. So what are we going to test for? We're going to first test, make sure our initialization works. And then we're going to test our start routine. Our start routine is going to start and eventually end. And that's it. So what about number 4 here? Rounds played until there is a winner. Well, we don't need to test for that because if we start the game off and then it ends, the rounds automatically get tested because it has to. If we expect certain things to happen, like a certain player to have won a certain number of cards within a deck, or a certain number of cards are left over in the deck for each individual player, then we know that the round works. If those are not correct, if what we expect at the end of the game is not correct, then the rounds have not worked. So there's no need to have it as special system or special testing for the playing of the rounds. So with that said, we know we're going to have a constructor. We know we're going to have an initialized spec. So we'll create the initialized spec. And we know we're going to have a what did I call it? Start spec. That's right. So let's take a look at the constructor first. All right, let's throw some code up there. Okay, and here's our code. Here's all the different tests. So basically, when we construct a game, it should obviously return a game. I mean, we do that with all of our objects here. We want to make sure it actually does return an actual game. We're checking to make sure that the default has an actual string in it. Or is defaulting to a string. We're going to sit there and make sure that the default players is an array and has a length of 0. So in case there's no players or no ID specified, everything is defaulted correctly. We want to make sure to return the ID if it is actually specified. If the ID is not a string, we want to make sure that it throws an exception. If the player's array is not a array, we should throw an exception. And this is basically how we do it. We just pass bad or something like that into a specific array. And we should throw an exception if it does not contain all players. And basically what that means is that if we do pass an array, that array has to contain an array of player objects, which like I said, we've created in other videos. So that takes care of all the what we need to do for the constructions. Once we do all of this, then we know that our constructor is correct. The IDs have been set, the players have been set, and all that kind of fun stuff. So I'm not even going to run it right now because obviously once we run it, everything's going to fail. So that takes care of the constructor. So what are some of the things we're going to want to do inside the initialization? Well, let's take a look at that code. Okay, here's the code for the initialization. So let's take a quick look at it. First of all, I did put some comments up here to kind of tell you what I expect it to do. I expect the new deck to be initialized, and we're going to be passing a starting dealer to this deck. and that the players are dealt their starting hands. So what we're going to test for here is that, first of all, we do initialize a new deck, a deck of cards that gets dealt out to all the different players, and that each of the players that we pass get the correct cards that we expect. Because basically, once we start with a particular dealer, it's going to go in a counterclockwise motion or array order motion and deal out one card at a time. So we're going to have to make sure that we know the sequence that our cards are in, so that when they get dealt out, we can then test to make sure those sequences are correct. So very simple here. We got a number of players. We're only going to check for 2 players. Now, our game does 4 players. We're only going to check for 2 because it's all we really need to check for. If 2 works, 3 works, and 4 works. So there's really no need to go past that point. And cards per player, we got set for 5 here. So before each test runs, I'm going to create 2 new players and get that array and set the dealer to player A, which means that the first card will get dealt to player B. And then I'm going to create a new game with players inside of it. Real simple, no big deal. All right, so first should throw an exception if the dealer argument is not a player instance. Okay, very simple. So basically what we want to do here is that when we initialize the game, because basically once we create the game, which is what this part is here, the next thing we're going to do is we're going to initialize it. And when we initialize it, we're going to pass a dealer to it. And this dealer must be a player instance, and this dealer must be a player instance, so that's why we're testing for that. The second one here is that we should throw an exception if the dealer is not present in the player collection. Obviously, if we set a dealer that is not part of the players, it kind of defeats the purpose. So I've created myself a new player as the dealer, and so I expect that to, if it gets to line number 42 here, I expect it to be false. Otherwise, it gets thrown an exception. In this case, I'm throwing a range error. So the third one is it should create a new deck of a 52 card standard deck. So I'm using the standard decks system here, so we should be able to create a new card which has 52 decks in it. So to be able to test for that, we're going to make a copy deck of the standard card deck. Now, where's that standard card deck coming? Well, let's take a look at our imports at the very top here. Standard card deck is coming from our standard deck.javascript file. And we use this a lot within the round section there to be able to, these are, let me just actually bring it up here. This is a deck or a grouping of objects here that represents different decks for the different players, for dealing the cards, initializing the test, all the kind of fun stuff that is associated with all these different tests. But this gives us the ability to know that we're going to have this is a copy basically of a 52 card deck, which gets the mapping that we're going to be using for the mapping of the values we're going to be using in our game, plus gets the standard ranks and the standard cards from the standard card deck, which is one of the NPM NPM repositories that I offer that you can download free of charge, take a look at it, and you can use it within your games should you desire to do that. But that's where we're getting the standard deck from and the copy deck. So I'm making a copy of the copy deck so that I have now a deck of 52 cards. I'm going to initialize with the dealer, and my dealer happens to be player A, as we say in line 27 here. So what I'm going to do here is while deck is linked. Now remember, with an initialization, I know everything is going to get shuffled. So when we've initialized it with the dealer, we know that the cards are going to get shuffled. So we got to be able to make sure that every single one of those cards are that we have within the deck are part of the are within the deck of the cards. So I want to check first of all to make sure that the card is within the in-game deck. This is the deck that has all the cards that get dealt off to the players. I also want to check to see if the card is within player A or the card is within the deck for player B. And so I'm just basically saying that since find card will return a -1 if it's not found, I'm making sure that the maximum of in-game in player and in player B is greater than or equal to 0. If it equals a -1, that means that card wasn't found, and that means that we don't have a valid 52 card deck. And so we will make sure that, if we don't have the valid 50 card deck, then result will come back to be false, and therefore it'll die on us in that case. So this is how we check to make sure that we have a full 52 card deck that is within this initialization, and it's either in the main deck for the game or it's in player A or within player B, because the initialization shuffles and deals it out. So that takes care of that one. What about the fourth one here? That should deal 5 cards to all of the players. So this just checks to make sure that we have actually dealt 5 cards. Now, Do we care what 5 cards have been dealt? No, because they've been shuffled, and we already had a test to make sure that those cards are legally 52 cards. So we know they're all legal, and so I don't care what cards they got. I just care they've actually got 5 cards. So I expect both those cards to be card counts to be card players, and I expect the card count for the game deck to equal to the copy deck length minus the card players times the number of players. So that basically means I'm checking to make sure that the deck for player A is correct, the deck for player B is correct, and the game deck has fewer cards than what it started off with. Next test, should throw an exception if the callback arguments are not a key value collection. And what are the callback arguments? Well, one of the things I noticed that when I was working with started doing the very quick browser game to make sure everything's up and running, I need to be able to have hooks into when things happen. Hooks when to be able to say, hey, just before you start a round, call some code. Just after you start a round, call some code. Just before you determine the winner, start code. Before you end the winner, start some code. And that is passed within the callbacks argument. And so basically the callbacks is a key value collection of different functions. So what I'm checking for here is that if we initialize the callbacks, which by default is null, blank, then I want to check to make sure that they are actually a key value collection, which means it's got to be an object. So this test to make sure it's going to be an object. And then finally, the last one here, it should be a collection of functions. So I'm just throwing callbacks inside there called A and B to make sure that these are actual functions. And we'll be getting into callbacks a lot later into the system. When we start doing our unit test on the browser game, we will start opening up what these callbacks are all about, because that's where they're used. There's really no need for them to be able to use within this game itself. So we got all that done. That takes care of the initialization. What about the start spec? Well, let's pull up that code. Okay, so here's the code for the start spec. Now basically we've still got another before each here, which is basically the same as the initialization, except I actually call initialize here. So the idea here is that we call basically a game start, which is right here in line 50. And I'll get to explain exactly what all this here is in just a second. To get to this game start, basically what we're done here is that even though the initialization has dealt all the cards, we want to be able to know exactly what cards are within the player's hands, because the idea here is that when we play a round or when we play a game, at the end of the game, we should have a set number. We should be able to test what each player has in relationship to their cards and who has actually won. By doing that, we then know that the round is correct and completed, and we don't have to test for the round. So to control the outcome, we're going to be setting player A to have the ace of clubs and the two of clubs, and player B to have the king of clubs and the queen of clubs. We'll remove all the different cards from the game and add in those 2 more. That way we know there are only going to be 2 rounds played, and that player A will have their cards. Player B will be the winner of both of these cards. Now, also when player A gets after player A after the first round, player A is going to need cards. We're also going to set it up to where the deck will deal him automatically the 3 clubs and the 4 clubs, so that we're guaranteed to lose both of the rounds. So that's what all of this setup is for right here. This basically, I remove all the cards from player A and player B. I force certain cards into player A and player B. I remove all the cards from the deck, and then the draw deck, and then I automatically put the 3 and the 4 in there to be absolutely certain that they get a 3 and the 4. Okay. So then we use Cypress to be able to run the game. Now the game itself it has to be in a promise format. And the reason it's in a promise format is that we have human players available. Now if everything was in AI, everything is automatic. We don't have to worry about anything. We just go straight through it. But because there's a player, it's going to be asynchronous, because we always have to wait for that human player to be able to select their card when they want to be able to lock down their card. Therefore, since it's asynchronous, everything's going to be run inside promises. And to be able to do that within Cypress, we first of all wrap a null wrapper around create a Cypress promise by wrapping an object. Once we do that, it creates a Cypress promise, and then we use Cypress's promises to be able to control what's going on. So after we do the Cypress promise, then we run the game start. And once we run the game start, since it is a promise, the game start is not going to resolve itself until it is finished. And it's going to finish under two certain situations. Either there has been a problem, there has been a final winner with the game, or there has been some sort of exception that has occurred because, you know, a human player timed out when they were trying to run the game. So that's one of the things that we're, you know, for instance, if they drop out of the game. So that's the two things we're going to need to check for. So this first check is that we should start the round and play until the end. So game start plays the entire game, and once it's finished up, it has certain values. We're going to have a game over property. It's going to be set to true. We're going to have a winner property, which is going to be set to who the winner is. We're going to have an error property, which is going to be set to null, which means no error occurred. We're going to have the rounds property, which is a listing of all the or a collection of all the different rounds that are with the game. That's going to be set to 2 because we know there's only going to be 2 rounds in this game. Again, because we made absolutely certain that we hard-coded everything to have 2 rounds. And we will expect rounds 1 round number to equal to 2, which means that the round numbers are correct. So the game is checking the round numbers, it's checking the round lengths, it's checking the error, the winner, and the game over. So that will check to make sure that we should start the round and play until the end. Now, there is another possibility we should error out if a player drops out of the game. If a player drops out of the game, then obviously we got another problem there. We should start the round and stop when a player drops out. So we get everything set up, but we're setting for human true here. So we're going to initialize, we're going to set the game, we're going to set the initialize, and then we're going to set the game start. And it will immediately kick back out because it's a human player. So it's going to time out on us saying, hey, there's nothing we can do here. So the game over is going to be set to true. The winner is going to be set to null because we're going to expect the winner to be set to null because there's been no winner. We're going to set the exception name of the error to be error and the error player to be player B, which basically says, hey, player B is the one that caused the error. They weren't there because they're human and we have no human interaction within the code itself. It just basically sits there and says, okay, I'll wait for the 3 seconds to be able to, 3 seconds are up, nothing happened, so I'm out of here. We're going to stop this game because there's no need to play the game because the human's not responding to us. And that's basically it. There is nothing else to do. We should, start the round and play until the end, and we should start the round and stop when a player drops out. And again, why are we not testing the internal workings of the round? Well, we don't need to, because all we need to do is that the process here, once we start the game, and once it ends, if it ends the way we expect it to end, that means the rounds have to work. So although we'll have a round function within our game eventually, or some sort of play round or something like that, we don't have to actually test for it because it's just not important. What's important is that we started the game and that we've ended with the results that we expected to end with. And that's basically it. We've constructed the game, we've initialized the game, and we started the game. There is nothing else to do. So let's say, whoops, forgot to save it. Let's say we run it and see what happens. npm run test e2e ci e2e2 excuse me ci, and I'll see you on the other side. Okay, and we're done. And oh yeah, look at this: 6 failures here, a failure here, a failure there, a bunch of different failures. Why are there failures? Because there's no code. So of course there's no failures. So that basically completes our working on the test for the game. So the next thing we're going to take a look at on our next video is the game object itself. If you like this video, please click on the like button below, subscribe to this channel, or leave a comment. I'd love to hear from you. And again, thank you so much for watching the video. This is the Virtuoid, aka Mike Smith. We'll see you later.